Hello, MongoDB developers. This is the first episode of our series on writing better queries. Today we're going to talk about how to make your queries faster. Here's a simple fact that might surprise you. To speed up searches, try searching for exactly what you're looking for. Sounds straightforward, right? But the real question is, how do we achieve that? The trick lies in filtering. Even though MongoDB is known for being schema-less, your data isn't just floating around without any order. It has a structure, a pattern. By understanding and leveraging this structure, we can fine-tune our filters to be more selective, thereby delivering the results set faster. In this episode, we're using a sports tracking app as our playground. Let's take a look at how optimized queries can make data retrieval not just faster but smarter. Here's the initial query. It's searching for running tracks, but it's not specific enough. So it searches all possible running tracks and returns a lot of data, making the fetching process slow. Now, let's optimize our query. Our application doesn't display all the tracks in the world, just the ones nearby. To archive this, we're using the $near operator to search for tracks within a 5-kilometer radius of our current location. This way, we're not just filtering by activity type, but also by location. This makes our query more selective and our search area smaller. The result: a query that's 150 times faster and shows only useful data. This can be any other filter, not just a geospatial one. The point is to be more specific in your search. The opposite case can also slow down your queries. It's easy to fall into the trap of building a query iteratively, adding more and more components as you go. But if you're not careful, you might end up with redundant parts that are evaluated anyway. This is like packing for a trip and ending up with 3 pairs of shoes when you only need one. It's not just unnecessary, it's also a burden. Let's take a moment to explore our MongoDB document structure. Here we see our records tracking various types of activities. We have an activity type and a more specific activity subtype. It is useful for different grouping and filtering options. Now, observe as we venture into refining our MongoDB query. Initially, we've specified activity type walking and activity subtype Nordic. It's akin to using both a belt and suspenders. Effective? Absolutely. Necessary? Perhaps not. Let's streamline our query by focusing solely on activity subtype Nordic. There we go. It's about trusting our specific criteria to guide the query. The execution time got faster, and we've simplified our query. Amazing, right? Moving on to indexes, those critical components that can make or break your query performance. It's not just about having indexes, it's about having the right ones for your needs. Imagine we are designing a leaderboard for runners, focusing superficially on 5K runs. To find the fastest times for this distance, we employ the following query in our MongoDB database. This query files queries by type and distance before sorting them by duration to identify the quickest performances. Initially, we had an index solely based on total distance. This index helped us quickly locate activities within the specified distance range. However, as we refine our search to include activity types, we realize that this index is no longer optimal for our query's needs. To enhance our query's efficiency, we'll introduce a compound index on total distance and activity type. This adjustment significantly refines our filtering process, allowing MongoDB to more swiftly identify running activities with our desired distance range. But as we embrace the power of indexes, let's not forget the cost. Every index consumes resources, especially memory. It's crucial to strike the right balance, keeping the indexes that serve our queries well and letting go of those that don't. Here we're faced with an outdated index that's no longer optimal for our needs. It's time to declutter, creating space for more efficient operations and allowing MongoDB to optimize memory usage for performance. By removing this index, we're streamlining our database's resources, ensuring that only the most relevant indexes are in play. This, in turn, enhances the performance of our queries and the overall efficiency of our database. All right, let's wrap this up. To speed up our MongoDB queries, we need to be smart about what we search for and use indexes the right way. I'm Roman Wright. Thanks for tuning in. Stay efficient and see you next time.